In this demo, we'll show how to implement monitorable AI usage with cryptographic guarantees. To better understand our solution, let's start with a use case. Imagine we have three parties: an AI custodian with a very powerful model, an AI borrower who might benefit from using the model, but who the AI provider doesn't want to share the weights with directly, as they want to ensure they can only consume the model and not reverse engineer it. Finally, there is the end user. This could be the AI borrower, or it may be that the AI borrower resells the model to a separate end user. We can imagine, for instance, a scenario where we have OpenAI with GPT-4 being the AI custodian, a country which is not aligned with the US but who would benefit from GPT-4 for internal usage as the AI borrower, and specific departments or members of government of the country as the end user. The custodian wants to lend their model to the borrower without exposing their model weight's intellectual property directly. Let's now look at how Blind AI DRM can allow the custodian to share their model with the AI borrower with full visibility over the AI consumption, guarantees that weights are never exposed in the clear, and a manual switch that can be used at any time to block all usage of borrowed AI. The custodian will ship a secure enclave, which is a hardware-based, highly confidential environment that will ensure the weight's confidentiality. In a first phase, the custodian verifies remotely that the AI borrower has launched the enclave that the custodian previously shipped, and that the correct server is booted. This verification is done through a process called attestation, which provides cryptographic proof to the custodian that they are talking to a secure enclave and that anything shared with it will benefit from hardware isolation, so outsiders can't read or access the content of the enclave. Once the custodian knows that they are talking to an enclave, they upload the model securely. The model can then be consumed by untrusted parties, but the hardware guarantees that the weights are never directly accessible through memory isolation. End users can then consume the model, but by doing so, they reduce their computing budget. After hitting a predefined threshold, the enclave will lock itself and await further budget approval from the custodian. If no additional budget is approved, the model becomes useless. Further technical details about secure enclaves and attestation will be provided in the technical documentation. Let's now take a look at how this works step by step. We start with the custodian, who launches the custodian server on their infra and selects the model they want to make available for consumption. In this example, we'll use the COVIDNet model, which takes images of patient chest x-rays and returns a probability of this patient having COVID. They can set the number of inferences they want to allow the end user to be able to perform on the model before they run out of computing budget and the enclave locks itself. The custodian server will now wait for a connection attempt from the enclave server and verify that it is a genuine enclave with the right hardware security through the attestation process. Once the enclave is verified, the model is then uploaded. If I now launch the enclave server on the AI borrower's infrastructure, we can see that a connection is established and the model is successfully uploaded. Let's now jump over to the end user's point of view. They can query the model using the client interface. They select the chest X-ray image they wish to query COVIDNet with, and provided they have not run out of computing budget, they will get back the result. If the end user attempts to send more requests to the model than they have been allocated, the enclave will lock itself and await for the custodian to approve or deny additional computing budget. If they enable more requests, the end user could continue to query the model. The custodian can press a button at any time to manually self-lock the enclave, cutting all end-user access to the model. All new queries by end users to the model will now fail. To find out more about how the model is protected, check out the documentation provided with this video. Thanks for watching.